Okay, now for question number 12, we need to rank a number of forces. The first one is a normal force of a 25-pound dog on a ramp at 25 angle above the horizontal. Okay, the second force is a weight of cat. We need the third force is a force for a spring. The final one, the fourth one, which is a static friction force. We need to compute each forces and then rank them. For the first one, we have a dog on a ramp with 25 degrees. We have the weight for this one dog, which is m phi g in g, but we need it in kilograms, not in pound. We have 25 pounds. We need to convert it using this conversion coefficient. I need to cancel pound, then I need the pound to be in denominator, okay, to cancel it. So I will use this one. 25 pounds multiplied by 1 over 2.205. This will be equal to 11.38 kilograms. You can approximate it to 0.4. Okay, now we can find the weight for the dog, which is 11.38, which is the mass, multiplied by g. This case will be the weight is 111.11 newtons. It is downward. This force has a slope with respect to our surface of motion. Our surface of motion is 25 degrees above the horizontal axis. Okay, so we have two components for this force. That force, this angle is 25. It's the same like this one. This angle 25, the component in direction of this angle will be the weight, which is mg, multiplied by cosine, because it is that direction of the angle, and this direction is sine. We don't need it. We need the normal force. The normal force is related to the other normal force in our surface. Okay, so note that the normal force is 90 degrees with respect to our surface. Always the normal force is 90 degrees. Okay, it is not upward. If you draw it in this case, in this way, this is the normal force, that's wrong. It will be with 90 degrees, the normal force. And it is equal to mg cosine theta with negative sign to tell us about the direction, but we need the magnitude, just the magnitude, so we don't need the sign. The magnitude of this normal force is the weight multiplied by cosine 25, which is 100.7 newtons. This is the first force. The second force needed is the weight of the cat. The cat has 5 kilograms. Its weight is 49 newtons. This is force B. Force C, which is the force of the spring. We need to use or to calculate Hooke's force, which is K multiplied by X. K is 1050 newtons per meter and the displacement X is 5 centimeters. 5 centimeters means 0.05 meters. How I can find it? It is easy. I need to multiply the 5 centimeters by 1. 1 is 1 meter over 100 centimeters. It is a conversion coefficient. This value is 1 because 1 meter is equal to this value. I can cancel centimeters. Then I have the rest unit is meter multiplied by 5 over 100, which is 5 in 100. okay, meters. This is X. Now I can find the Hooke's force, which is the Hooke's constant for this spring multiplied by the distance or displacement. It will be 52.5 newtons. This is force C. The final force, which is a friction force, is equal to mu s, because it is static, mu s multiplied by the normal force. We have a mass, 25 kilograms. We need to find the weight downward and then find the normal force upward. In magnitude they are equal, but there is a negative sign between them to tell me about the direction, but I don't need it, because I need just the magnitude. The magnitude for this force, which is the weight, which is the same as the normal force in magnitude, which is 245. I use it here, multiplied by the mu s, which is 0.2. The final value is 49 in Newton. This is FD. Okay, now we have four forces. FA is equal to 100.7, FB 49, FC 52.5, FD is equal to 49. We can order them now. FA is greater than or bigger than FC, which is greater than FB, which is equal to FD. Now we can order them. Be careful to how to compute each force. We have left question number 13. Thank you.